So today we're going to discuss the problem 21.74 from exam 1. The initial problem states that two tiny spheres of mass 6.80 milligrams carry charges of equal magnitude of 72.0 nanocoulombs but opposite sign. They are tied to the same cylindrical by light strings of length 0.530 meters. When the horizontal uniform electric field E that is directed to the left is turned on, the spheres hang at rest with an angle U between the strings equal to 58.0 degrees. We have two parts to discuss. A, which ball has a positive charge, and B, what is the magnitude E of the field. So first of all, we have to sketch the approximate graph of our problem, and that would be something like that. Two strings and two attached spheres. The length of each of those strings are just L and L, and the angle between is alpha, for example. Also, we know that the electric field E is directed to the left. For future calculations, we can also state that this angle alpha can be described as two angles alpha over 2 and alpha over 2 as well. So, discussing part A, which sphere has a positive charge, we can say that those two spheres have opposite charges, therefore they are attracted to each other, basically. Plus, as I said before, the electric field is directed to the left, plus we have the gravitational force and tension that bring the both spheres to the original position, while the electric force, the direction, which is to the right side, pushes those charges apart from each other. So, based on those statements, I would say that the left sphere has a positive charge, while the right one has a negative charge. So that's basically the answer for part A. Moving on to the part B. What is the magnitude E of the field? So to start with, we have to convert some values that we have, the mass and the charge, because we have to use kilograms and coulombs instead of milligrams and nanocoulombs in the formula. So we just need to move this here to grab some space. So basically, the mass equals 6.80 milligrams equals 6.0 multiplied by 10 to the power of negative 6 kilograms. And the charge that equals 72.0 nanocoulombs equals 72.0 multiplied by 10 to the negative 9 coulombs. Also, we have the length of the string, which is 0.530 meters. So basically, we have to use a sigma notation. We have to describe the segmentation for x and y directions, and rewrite it as the formula for t. So doing this, we get this sigma notation for y direction. And this as the sigma notation for x direction as well. After that, we can rewrite it as the formula for t. That equals mg over cosine of our half of the angle. So it would be alpha over 2. This would be for y direction, and we also can write the formula for a electric field using this formula as well. So it would be t multiplied by sinus of alpha over 2 as well over q plus force in the numerator. So we do have these two formulas here for t and e, which we will use after determining the equation for the distance between those two opposite charges, which is very important. So basically, we do have the d, which is the distance, and the distance squared between these two spheres with opposite charges, so is 2l squared of sinus alpha over 2 plus 2l squared multiplied by sinus squared multiplied by sinus squared of alpha over 2. So from this equation, we can find the d, which is just 2l sinus of alpha over 2. Next is force that we also have in this equation that we need to use. So the force will be equal kq squared over d squared, so distance squared. So basically we have three notations for t, d, and f that we can substitute into this equation of electric field and find the magnitude of this electric field. So substituting those notations, let's just write it right here again. So we substitute in this for t, So we can just copy that. Multiply by sinus of alpha over 2 plus f, which is kq squared over d squared. We can substitute it as well. And over q. And that will be equal mg multiplied by tangent of alpha over 2, because we have cosine and sine, so sine goes to the numerator and cosine to the denominator, so sine over cosine is tangent of alpha over 2 and over q as well, and plus kq over d that we have here. So this notation goes here because d squared is this one, so this will be squared. So now we have all the information we need, and we do have all the values, so we just insert it here. So the mass is 6.80 multiplied by 10 to the negative 6 kilograms. Multiplied by G, which is 9.8 meters over seconds squared, and multiplied by tangent of alpha, which is 58 degrees over 2. And Q is 72.0 nanocoulombs, or 72.0 multiplied by 10 to the negative 9 coulombs, plus kq, so k is a constant, and equals 8.988 multiplied by 10 to the power of 9. And multiplied by q, the same value we have here. And that will be over 2L. L is 0.530 meters multiplied by sinus of alpha, 58 degrees over 2, and squared. So calculating, we get 3.6964 multiplied by 10 to the power of negative 5 over 72.0 multiplied by 10 to the power of negative 9 plus 647.136 over 0.2641, and that's gonna be 513.044 and over 3 plus 2,446.558 n over c. And that equals 2,959.6 n over c. And that is the final answer. So this is the magnitude of our electric field. So let's just write the answer for both parts. So for part A, the answer is the left sphere or ball has positive charge, and the answer for part B is the magnitude of electric field is 2,959.6 n over c. That is the final answer for the problem that we have.